H2 gas 1 atmosphere pressure, H plus salt bridge. Here in place of Cu plus 0.01 molar, it should be Cu plus 2. Concentration is 0.1 molar. Cu. Calculate E cell for the cell if the standard reduction potential of copper electrode and SHE is plus 0.34 volts and 0 respectively. First we'll write the anode and cathode reactions. Anode is a hydrogen electrode. Hydrogen will undergo oxidation. H2 gas pressure is 1 atmosphere gives rise to 2H plus aqueous plus 2 electrons. Cathode is copper. Copper will undergo reduction. Cu plus 2 aqueous plus 2 electron gives rise to Cu solid. Overall cell reaction is H2 gas 1 atmosphere plus Cu plus 2 aqueous gives rise to 2H plus aqueous plus Cu solid. Q is equal to product concentration by reactant concentration. Anyway, solid concentration is 1 molar. H2 gas pressure is 1 atmosphere. So remaining is H plus power 2 by Cu plus 2. That is Q. Now E0 cell is equal to E cathode minus E anode. Cathode is copper electrode, its reduction potential value 0.34 minus hydrogen electrode is 0. So its E0 cell value is plus 0.34 volts. E0 cell value. Now the nearest equation is E cell is equal to E0 cell minus 0.0591 by N log Q. E cell is equal to E0 cell value is 0.34 minus 0.0591 by 2 log H plus power 2 by Cu plus 2. Now E cell is equal to 0.34 minus 0.0591 by 2 log H plus concentration is 1 molar because standard hydrogen electrode, so its H plus concentration is 1 molar by Cu plus 2 is 0.1. So 0.34 minus 0.02955, that is 0.0591 by 2 log 1 by 0.1, you can write it as 10 power minus 1. So 0.34 minus 0.02955, 10 power minus 1, if you bring on top it will become 10 power 1, that is log 10 is 1. It is 1. So here we'll get, if you subtract, we'll get the value 0.31045 volts. So the answer for this question is 0.31.